Hello and welcome to my video. The purpose of this video is to analyze and verify the DC electrical characteristics of the popular general purpose amp NE5234. NE5234 is a match, low voltage, high performance quiet operational amplifier. Some of the applications of this NE5234 is a match, low voltage, high performance quiet operational amplifier. Some of the applications of this amp is the automotive. This is the bias circuit of the NE5234. As you see, transistor 5556 and 4951 act as a complementary emitter follower is utilized instead of using single transistor to reduce the supply voltage. This is the B-Spice stimulations of the NE5234 bias circuit. As you can see, the current compared between the calculations numbers and the stimulations are pretty similar. Also, the emitters area of transistor 60 is This is the input state of NE5234. No bias 1 comes from the reverse bias circuit. If the common mode input is much less than 0.5 volt, the current of transistor 11 will flow through transistor. This is the piecewise stimulations of the input state. As you can see, transistor 9 and 10, 13 and 14 are operated in the active mode with 6 microamp, but in the stimulations we only have 3. This is the schematic of the NE5234 second state. As you can see, node 9 and 10 are coming from the first state. Also, capacitor 21 and 22 are for the frequency compensations. This is the piecewise stimulations of the second state. The current of C15 flow through the diode D1 and create a voltage drop of 0.4 volt. Also, the area of transistor 29 is 7,000. This is the bias circuit for the output state. In class AB common collector's output state, the product of the current is a constant. In the NE5234 ARM, the transistor can never turn off. The collector current. This is the piecewise stimulations of the bias circuit for the output state. The current between the calculations and stimulations are similar. In theory, the transistor can never be turned off. However, due to voltage drop in the base and emitter resistance, this is the schematic of the output state. NE5234 does not use an emitter follower configurations for the output due to the low supply voltage limitations. In node 25 and 26, are the inputs coming from the. This is the overall gain of the NE5234 ARM with closed loop gain of 10 and open loop gain of 100. The gain figures of the open loop. This is the NE5234 piece by frequency response. For the closed loop frequency response, the 3dp point was found at when the frequency was at. This section is to compare the performance of the multiple stimulation circuit that I discussed reverse with the built-in NE5234 in PSPI library. This is the NE5234 built-in ARM gain stimulations result. As you can see, the closed loop gain and the open loop gain is pretty much similar to the. This is the built-in NE5234 PSPI frequency response. The closed-loop frequency response are exactly similar to the multi-stage stimulations. The 3dp point was marked. This is the schematic of the two-stage CMOS operational amplifier. In this sections, our CMOS two-stage amplifier will be designed based on the NE5234 and this is the stimulations of the two-stage CMOS operational amplifier. The gain from the closed loop and open loop result, which is really close to this is the frequency response of result of the two-stage CMOS operational amplifier. For the closed-loop frequency response, the graph came out similar to the BGT stimulations, but on the other hand, the open-loop frequency response